Crossing the line and load in a breaker panel is illegal and poses significant safety risks. This configuration can create several dangerous scenarios that violate electrical codes and endanger individuals and property. Firstly, crossing the line and load can lead to overcurrent situations. When the incoming power line is directly connected to a circuit intended for a load, it bypasses the circuit breaker's protection mechanism. The circuit breaker is designed to trip and interrupt the current flow when it exceeds the rated amperage of the circuit. However, if the line is crossed with the load, the breaker may not function as intended, allowing excessive current to flow through the circuit. This can cause the wires to overheat, potentially leading to insulation melting, arcing, and ultimately, an electrical fire. Secondly, this improper wiring configuration can create a ground fault hazard. A ground fault occurs when an unintended path for current flow develops between a live conductor and a grounded surface. Normally, the grounding system provides a low impedance path for fault current, allowing the breaker to trip quickly and clear the fault. However, when the line and load are crossed, the grounding system may not function correctly, increasing the risk of electric shock. If a person comes into contact with a grounded object while a ground fault exists due to cross wiring, they could receive a severe or even fatal electric shock. Thirdly, it can damage electrical equipment and appliances. Electrical equipment and appliances are designed to operate within specific voltage and current ranges. When the line and load are crossed, the equipment may be subjected to voltage levels or current flows that exceed their design limits. This can cause damage to sensitive electronic components, motor windings, and other internal parts. In severe cases, the equipment may be rendered unusable or pose a fire hazard. In a standard breaker panel, the line side refers to the incoming power conductors from the electrical supply, typically the utility company. These conductors carry the main voltage to the panel. The load side refers to the outgoing conductors that feed the individual circuits within the building. Each circuit is protected by a circuit breaker that is connected in series with the load. The neutral wire provides a return path for the current to the source, and the ground wire provides a safety path for fault currents. When wiring a breaker panel, each circuit must be connected to its own dedicated circuit breaker. A hot wire from the circuit is connected to the breaker terminal, and the neutral wire is connected to the neutral bus bar. The ground wire is connected to the ground bus bar. The neutral and ground wires must be kept separate except at the main service entrance. This separation ensures that fault currents have a clear path to ground, minimizing the risk of electric shock. Circuit breakers are essential safety devices that protect electrical circuits from overcurrents and short circuits. They are designed to trip and interrupt the current flow when the current exceeds the breaker's rated amperage. This prevents the wires from overheating and potentially causing a fire. Circuit breakers come in various sizes and types to accommodate different circuit requirements. The appropriate breaker size should be selected based on the ampacity of the wires and the expected load on the circuit. Ground fault circuit interrupters, or GFCIs, are another type of safety device that protects against electric shock. GFCIs monitor the current flow in a circuit and quickly interrupt the power if they detect a difference between the outgoing and return current. This difference indicates a ground fault, where current is leaking to ground. GFCIs are commonly used in bathrooms, kitchens, and other areas where there is a risk of water exposure. Arc fault circuit interrupters, or AFCIs, protect against electrical fires caused by arcing faults. Arcing faults occur when there is an unintended arc of electricity between two conductors. These arcs can generate high temperatures and ignite flammable materials. AFCIs detect the unique characteristics of arcing faults and quickly interrupt the power to prevent a fire. AFCIs are typically required in bedrooms and other living areas. To ensure electrical safety, it is crucial to follow all applicable electrical codes and regulations. The National Electrical Code, or NEC, provides comprehensive guidelines for the safe installation and maintenance of electrical systems. Local electrical codes may also have additional requirements. When working with electrical systems, it is essential to use appropriate safety equipment such as insulated tools, rubber gloves, and safety glasses. Always turn off the power to the circuit before working on it, and verify that the circuit is de-energized using a voltage tester. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician. A qualified electrician has the training and experience to safely install and maintain electrical systems. They can also identify and correct any potential hazards. Improper wiring can lead to a variety of problems, including electrical fires, electric shock, and damage to equipment. It is essential to follow all applicable electrical codes and regulations to ensure electrical safety. If you have any questions about electrical wiring, consult a qualified electrician. Never attempt to work on electrical systems if you are not qualified to do so. The risks are simply too great. Always prioritize safety when working with electricity.